Good evening, everybody. Welcome to Lesson 10 of Lambda School's Mini Bootcamp. My name is Deandra Ryan Moss, and I'm your instructor. So we're now on Lesson 10 out of 12, so we're getting very close to the end here. We have tonight and tomorrow to cover 2 more advanced JavaScript topics, and then we're going to round out the whole series by learning about the DOM, which will tie all the topics that we've learned over the last 3 weeks together. So I hope you guys have been enjoying this series and learning a lot, and I hope that you're ready to learn a few more crazy things before we wrap this up. So for anyone who is joining us tonight for the first time, let me tell you a little bit about Lambda School and about this bootcamp. Lambda School is a computer science and web development immersive. So it's a 6-month full-time program where we take you from the point where you just know a few things about JavaScript and programming, web development, and we get you to the point where you are ready to be hired as a full stack engineer in the industry. And over the course of that time, we teach you a number of topics. We deep dive into everything that you'll see in this bootcamp, in this mini bootcamp, such as front-end web development topics like HTML, CSS, and JavaScript. We also cover back-end JavaScript frameworks and computer science topics like Python and C. One of the frameworks that we look through when we developed our curriculum for Lambda School is not only teaching you what you need to know, but teaching you how to learn what you will need to learn on the job. So something that makes being a developer a really unique job is that things move extremely quickly in this world. So the skills that you're learning in Lambda School are always going to be the most up-to-date, most relevant topics in web development, but within a year or 2 years, or definitely 5 years, that could change completely. So in the job force, not only do you need to use the skills we teach you, but you also will need to learn new frameworks, new topics, new languages as they come up. So one of the things that we look at in this school is not only teaching you what you need to know, but teaching you how to handle the unknown and how to handle something unfamiliar. And so when you're ready to be hired out of Lambda School, not only will you have those skills to jump into the job at that moment, but you'll have the skills to keep growing as a developer. So one more thing I wanted to mention about Lambda School that's really unique is our tuition model. So in order to keep the Lambda School open to as many people as possible, we do not charge anything upfront. So you are welcome to do an income share agreement with us, which means that you don't pay anything initially, but once you get hired in that full-time web development position making over 50K, you will pay us back over your first 2 years on the job. So if you don't get that job, we do not get paid. So that's a really cool thing that we do to, 1, make sure that we're keeping the door open, and 2, make sure that we're held accountable in getting you where you need to go, which is into that job. So enough about Lambda School. I'll fill you in a little bit on the mini bootcamp. If you are new, we're in the middle of week 3. We're pretty deep into JavaScript. So if you are new to JavaScript, this might not be the best place for you to start. I would definitely recommend going back and watching some of the old videos to get yourself caught up. Or if you'd prefer, you can wait a couple weeks and jump in on the next mini bootcamp, which is always nice because then you're watching in real time and you can ask questions. But either way totally works. So without any more preamble, I will go ahead and jump into our topic for tonight. So once again, this last week is getting into some deep topics. And kind of tying into what I just said about one of the most important pieces of being a programmer is being able to contend with the unknown. So there's a great opportunity for you to practice that in this bootcamp because we are introducing you to some pretty sophisticated ideas that take months to master. And the point of this bootcamp isn't to get you guys to master them, it's to just get your feet wet. So as we go through the topics this week especially, I would definitely encourage you to be really open to dealing with some complicated things that you might not fully understand from the get-go. And also to not be too worried if you don't fully comprehend them, because that's not the point. So last night we looked at callback functions. Callback functions are extremely important in JavaScript, especially in back-end JavaScript. They help us do asynchronous programming, which is a really fundamental piece of web development. And we didn't really see any asynchronous program in this bootcamp, but we got the skills in place so that you're ready to explore that when you get to the main curriculum. So with callback functions, we're able to actually pass functions into other functions. And this is a really unique setup because now we're not only thinking about what does one function do, we have to keep track of two functions that are functioning on two different levels at the same time. That's going to be really similar to what we see tonight. So tonight we're going to cover the topic of closure and scope. And once again, we're going to be working with functions in kind of this crazy way. So if you had fun last night, more fun to come tonight. Let me go ahead and share my screen and we can start learning all about scope and closure. All right, so let's talk a little bit, do a little bit of a review of some of the things we talked about last night. So there's this key idea that I opened with last night, which is that we can think about functions as more or less being like any other variable in JavaScript. So one of the ways that we're allowed to declare a function is we can create a variable name with our constant declaration keyword, and then we can set it equal to an anonymous function. And in this way, we're really just creating a function and saving it into this variable. And we're welcome to, if we want, we can declare another variable and pass around our initial function. And of course, we're welcome to pass this function into higher order functions like our for each method that we learned last night. So functions can be passed around in a pretty cool way. They can be passed around as variables, they can be passed into variables, and what we're about to learn tonight is that they actually can be passed out of variables. So we are allowed to return functions. So let me show you what this looks like with a really simple example. So I'm going to create this, this test function and have it return console.log. So this is a little interesting here, right? Because notice that we're returning the function, not the function call. And this was something else that I really tried to emphasize last night, is that when you have the name of a function, like console log, by itself, that is the function itself. This is the potential for something to happen. If you throw the parentheses on the end, you've now executed the function and you have the result. So in the case of console log, this would resolve to undefined because console log doesn't have a return value. But that's not what we want. We want to return the function itself. So if I now go ahead and call test function, well, first of all, if I just run the code on test function, we see that, of course, test function is a function, but let's call it. Now over here, this looked exactly the same because unfortunately, it's not giving us much feedback on what is inside of the function. But in this case, we've called this and it's resolved to our return value, which happens to also be a function. So test function itself is a function, but when we call it, the return value is also a function. It's just a different function. So let me clarify that a little bit by saving the return value into a different variable. So I'm going to call this return function. So now we have the test function, which I've explicitly written up here. And then when I call it, it returns this new variable, a return function. So I run this, and now I'm going to run return function. And notice that input is logged to the console. And as just a little reminder, we always know that something's logged to the console in Replit because it appears in white over here. So when I call return function, it runs exactly like console log. So I have effectively created a copy of console log in this return function. Of course, practically, there's no reason to create a copy of console log because we already have console log. But the takeaway here is that we're allowed to return a function. Just like we were allowed to pass a function in as an argument, like our callback, we're also allowed to return functions out of functions. So that's a little preview of what we're going to see tonight. Scope and closure are two key concepts that allow us to see why this concept of actually returning a function can be incredibly useful. So before we return any more functions, I want to talk to you guys a little bit about function scope. All right, so I've gone ahead and declared just an empty function here, nothing going on in it yet, and I've called it test function. And I'm going to use this to explain to you guys the word scope and how that's used in JavaScript. So first of all, I want to talk about the global scope. So anything that's declared on the outside of a function is part of the global scope. For example, test function is part of the global scope. I could create a variable called string. And this is also in the global scope. So this means that as long as I use the variable below where it's been declared, this variable is defined. If I just come up with a random variable name that's never been declared, we get a reference error because this is not within the global scope. It's never been declared. And as well as things that we explicitly declare, like this string and this function, we've seen some other things that are available in the global scope, such as the math keyword or any of its methods. Console is also a variable that's globally available. So there are some variables that are built in that are part of the global scope, and also anything we declare on this global level will be available to us. So within the function brackets, so quite literally between the two curly brackets, exists the function scope. So up here we have the global scope, and within here we have the function scope. And so anything that's in the global scope is also available in the function scope. So for example, if I did, let's just have this test function return the string. So string is part of the global scope, but we're allowed to use it within the function scope. And just to confirm that, I'll go ahead and call my test function. And we can see that it returns this string without a problem. So the global scope is available everywhere, but the opposite is not true. So if instead I create a variable in here, we'll call this number. So this variable has been declared inside of our function scope. So it is available within the function, of course. Otherwise, we wouldn't be able to do much inside of functions. So if I run this, it's going to run just fine. So this thing is available to be used in the return statement, but it's not available to be used globally. So if I try instead to access this variable called number outside of these brackets, outside of the function scope, we're going to get a reference error. So that is the biggest takeaway, is that whenever we declare a function, everything that happens inside of here is only available as long as inside of the function. It's not available globally. So while we can take global variables and use them in our function, we cannot take function variables and use them globally. And this is why return statements are so important. So since we have no way of accessing these variables that exist inside of the function, we need some way for the function to communicate with the global world. And that's what return statements do. So whatever is returned is going to be available, because we can now, if we want, call test function and return that value into this number. And now number is available for use globally. But if it's not in the return statement, it's not available once the brackets are finished. So that is the takeaway of scope. And one other thing that I just want to mention is that we are allowed to, we would have to do, let's use variable. I think constant will get mad at us for this. But we are allowed to create a new variable with the same name as something in the global scope. We'll actually make this a string. We can do that if we want, but it's really best not to. You want to try and keep your variable names unique, because otherwise it just really invites a lot of confusion for your fellow developers or your future self or your present self. So try to keep these variable names unique. Oops. So that is the gist of scope. And oh yes, one more thing I want to mention about scope, which is that just like there are some things that are available globally, like math or console, there are things that are only available within the function scope. For example, the this keyword or arguments are going to be defined within global scope, as we've seen when we learned about both of those keywords. But they're not defined globally. So, oops. Actually, this might be defined globally. It just isn't very useful. But let's try arguments instead. Okay. So when I try to run it, I get arguments is not defined. That's because arguments is a keyword within function scope, but not outside. And then the final thing I want to mention is that every scope is unique for different functions. So down here, I have a different function, but it has a new function scope. So I can't use the variable number that was declared in a different function. I can only use variables declared either globally or within this function scope. So this idea of scope is going to become more and more important as we dive into what closure is and how that works. So, so yeah, that is scope for you. And now that we have that down, let's go ahead and jump into closure. So let me start here. So I will start with a really simple example. Let's see. Call this get greeting. Well, let's start here. So if I want to create a function called greet that takes in a name and console logs. So we've seen something similar to this in a few other lessons. It's just a pretty simple greet function. And what it does is it just greets whoever's name is passed in. So we have one argument, this name, and then no return value, and we console log a greeting to whoever's name is passed in. So this is one way to create a greet function. But what if we wanted to create a greeting generator? So let me show you what I mean by that. So I will go ahead and comment this out for reference, and then I'm going to create a greeting generator down here. So I'll call this greeting generator. So this function also takes in a name, but instead of just logging a greeting, it's actually going to return a function that greets this person and only this person. So up here, this greet function, we can change whose name pops in, but now we want to create a greet that's actually bound to one specific person. So we are going to return a function. So in that first example where I showed you where I returned console log, I actually wrote in the name of an existing function. But of course, we're welcome to return a function that we custom create. So now I am writing in an anonymous function. And this is the function that greeting generator is going to return. And so this is where the actual greeting is going to happen. So I'm going to bring in this logic and say hi to whoever is going on here. So right now, this probably just looks like an extremely convoluted way of doing the simple thing up here, but they are actually subtly different. So let me show you how to use the greeting generator, and then we'll talk in a little more detail about why you might want to do it this way. So I'm going to create a new function called greet Andy, and then I will call greeting generator to Andy's name. So notice that when I call greeting generator, I'm of course putting in an argument of Andy, which matches to this one parameter of a name. And then the return value of greeting generator is a new function. So greet Andy is going to be a function. And we can confirm that by running it, and we see, uh-oh, what did I do wrong? Oh, forgot a comma. Let's try it again. So we can see that greet Andy is a function. And then let's go ahead and call it to see what it does. So this function greets Andy. So notice that versus the greet function up here, I'll bring this back. So if I call greets, I would have to actually put in Andy's name. And I could change it to anyone I wanted it to. Whereas this greet Andy function only will greet one person. It is bound to this name. So if I wanted to create a bunch of greeters that were bound to specific people, I could use this greeting generator. And now I have a greet Andy function and a greet Anna function. So you might be thinking, well, why would you create separate functions for each person when you could just use this more versatile greet function and just change people's name? And you kind of have a point in that I think in most cases, for this example, this would be the better way to do it. But there are two reasons I showed you this example. One is because it's just kind of a basic introduction into a concept that we're going to take deeper throughout the lesson. But the other reason is that you never know what sort of need or context your code will call for. And you might find yourself in a situation where instead of a greet function with a parameter, you might want just a greet function that is bound to a specific person and does not have a parameter. There very well could be a situation where that arises. And in that case, it would make sense to create a greeting generator so that you're not repeating yourself, because otherwise you would just be writing out. Oops. And you would have to write out this, you would have to write out this full function line for every single person. So say you needed 100 greeters bound to different people. You could write out a function for every single person, which would take several lines of code, or you could use a generator, and in just one call, you'd be able to create a new greeting function. So this brings us back to this idea of don't repeat yourself. Sometimes when you need to generate a bunch of similar functions, instead of having to write them all out individually, you can use this type of return statement to generate them really quickly. So I have kind of showed you a slightly more complex example of when you might want to return a function, but I haven't brought in scope or closure yet. So let me do that, because that is the whole point of the lesson tonight. So as I mentioned when I was going over what scope was, if you have two separate functions like greet and greeting generator, then the values inside of each of these can't be, the scope is unique. So if I created some random variable in here, this variable is not available within greeting generator. If I threw it in here, we'd get an error because it's inside of this scope. But what is allowed is if I created a variable over here, this variable is available within this anonymous function. That is totally allowed because this function exists. This anonymous function exists within the scope of our greeting generator. So everything that's available within this scope is also available within this scope. As you might imagine, the opposite is not true. If I moved this into here, it would not be available out here. So we would get a reference error. Let me clean up some of these examples real quick. Put this back. And in that similar vein, this name parameter, this name that's being passed in, is available only within the scope of greeting generator, but that means that we're allowed to use it in here. So you might have taken for granted the fact that I use this name argument within this anonymous function, but it's worth noting that that's allowed because parameters are only allowed to be accessed within the scope of the function. But luckily, this anonymous function is within that scope, so we can use that name. So we see how this relates to scope. Now let's introduce the idea of closure. So closure is what happens when we take a parameter from a function and then use it in the return function, we're said to have created a closure. So normally what would happen is once greeting generator was done being executed, this value of name is no longer available. It's been passed in, it's been run, and it's virtually disappeared. But because we've involved it in this return function, we've created what's called a closure. So now we're allowed to access it every time we call greet Andy. We're actually accessing a variable from greeting generator scope. So once again, this idea is called a closure. We would say that greet Andy has created a closure with this variable name, which was available in the scope of greeting generator. Once again, this is not the greatest example for showing the power of closures, but it's a good place to start. So now I want to move on to a couple examples that are a little more advanced, but that I think illustrate the idea of a closure a little better and illustrate why we would want to use it in a more clear way. So let me go ahead and move on to my randomizer example. And I actually have a few things written up here for it already. So before we jump in, let me just make sure you guys get everything that I've put on screen in advance. So first of all, I've just created these two arrays for us so that we didn't waste any time in class with me typing them out. So first of all, I've created a potatoes array, and this is kind of my redemption for last night. So I went ahead and did some potato research today and have some awesome breeds of potato listed here for you guys. So all you potato connoisseurs in the audience will appreciate this. I've also created a second array called JS topics. They're just some topics that we've seen already, maybe one that we're going to see later this week. And so these will just be a couple arrays that I use as examples. And then finally, I've created a helper function called random index. So this is a common bit of logic that you essentially have to use every time you want to get a random index in an array. I don't want to deal with this too much. If you guys are curious about it, we could talk about it in the questions. But for now, we'll just kind of skip what's going on in here. The important thing is how to use this random index. So if I have an array of length 9, I would pass in 9 to my random index, and it is going to give me a random number between 0 and 8. So keep in mind, because of 0 indexing, that an array of length 9 will have indices 0 through 8. So this will just help me create a random index on an array. And this will become important once I show you the next function that we're going to be writing. So, okay, so let's create a randomizer. So first of all, I'm going to do this in a non-fancy, non-scope or closure type way. So if I wanted to just create a randomizer for arrays, the most straightforward way to do it would be to have a function we pass in. So this is the, let me label it, non-closure approach. So I'm going to get a random index for this array. So I'll use my random index function. I'm going to pass in array.length. So now I is going to be a random index on that array. And then I will return array at index I. So this is just a normal run-of-the-mill function that takes in an array and returns out a random value from it. And let's use some of these test arrays to make sure our randomizer works. So let's get ourselves a random potato. Seems to be working. Let's just double check it with our JavaScript topics array. Also seems to be working. And I do want to say that this is totally valid JavaScript logic. And in many cases, this is how we would want to approach the randomizer problem. But let's say that we were in a situation where we didn't want the user to have access to this array. We didn't want the user to be able to specify the array. We wanted the user to be able to get a random item from it, but we didn't want them to be able to specify which array. So just like in that name example, we want a randomizer where the array is actually somehow bound So instead of calling randomizer and passing in the array, we want them to be able to just call randomizer and get a random element from an array that's been preloaded. And in order to understand this type of thinking or this type of coding, I do want to remind you guys that sometimes it's hard to see the usefulness of these approaches when we're just writing on a single page in Replit. But keep in mind that in the real world of programming, a lot of the times some bit of logic is going on behind the scenes in some file or some folder, and then one function is passed out. So it's totally possible that in a code base, in one part, this array would be preloaded into our randomizer, but then in some other part of the code, we would have access to the randomizer. So it's a little hard to see why you would do it this way in one page on Replit, because there's no separation of concerns. But in a real code base, you really do want to separate the logic. So it actually starts to make a ton of sense to preload things in this way. So let's use Clojure to preload in an array and create a randomizer. So I'm going to comment this out, and then I will create our higher order function. So this is that same term that I used last night can be used when we're talking about Clojure. In this case, this higher order function is a function returning a function. So let's go ahead and create something called generate randomizer. So this is the function that will preload an array and then return another function that randomizes it. So I'll go ahead and actually save this array into a storage variable up here. I'll admit that this line of code isn't per se necessary, but I think it helps clarify what I'm doing here. So I'm going to add it in. Okay, so I've created a storage variable. So this is something that exists within Generate Randomizer's Clojure, but it's going to be kind of hidden from the user of the return function. So now I want to return this randomizer function, and we're going to just steal some of this logic from up here. So let me bring it in. Okay, so now I've created Generate Randomizer. So I do want to really clarify what's going on here because this is a lot. So first of all, we want to think of Generate Randomizer as our higher order function. And it has one bit of input. It has one argument. Parameter would be the better word here. There's one parameter, which is an array. And it returns a randomizer function. So its return value is a function. Down here, we have the return function. Now notice that this thing has no parameters. So this thing will not take in any input. And then the return value will be an item in an array. So a random array item. So we are dealing with two functions here. The higher level function, the higher order function, which is a function generator. And in this one, we preload an array, and then we return a randomizer. And then we need to look in detail at the return function, which we see has no parameters, and it returns an array item. Oops, I put my white space in the wrong spot. Okay, so let's actually use this thing. So generate randomizer without a call is a function. It's a higher order function. But let's go ahead and call it. So this thing takes in one array. We'll put in our potatoes array. And so now that we're calling it, we know that when this code runs, it'll resolve to the return value, which is also a function. So when I call it, it resolves to a different function, this anonymous function down here. So if we want to use that function, we want to save it in a variable first. So we'll call this randomizer. Or we can even call it random potato, because more specifically, that is what this function does. It gives us a random potato. So now, if I call random potato, I get a random potato. And there is no way to get a random JavaScript topic out of this random potato function because it has been bound to this array. So it's cool because this array is an input on this function, but it's still bound to this other function that it outputs. And that is the whole idea of a closure. And so this variable of, actually, let's call this storage. So this variable called storage, which exists, it's been declared and exists inside of generate randomizer's scope, is available within here. So that means even after we're totally done executing this generate randomizer function, this variable from its scope is still available to us. It's out of sight and out of mind, but it's available in the sense that we're getting values out of it when we generate a random potato. And of course, this can save us time because now if we want to create random JS topic, we can use our randomizer and do the same thing. So now if instead of a random potato, I want a random JS topic, that works as well. And in this case, the closure has been created with the storage variable is set equal to the JS topics array. So in that way, even though these arrays and this generate randomizer function call could exist in totally separate parts of the code base, we could still use this function to get a random item out. And that's totally a valid use case because we might have a situation where we don't want whoever's using this function, we don't want them to be able to look into this array. I mean, if we, for example, wanted them to get one random thing but not see what the other options were, then we would want to create a closure because the storage variable becomes secret in this way. It's out of sight. It's totally inaccessible to this function. This function can get a value out of it, but it can't actually open the hood and see what is in that storage variable. So there's one more thing I want to show you with this example to tie it into closure. And I will, hopefully all these comments aren't getting too busy up here, but I want to show you this, actually. We'll leave this down here. All right, so I've created this random index inside of my return function. But what happens if I move this line of logic? So I'm going to move this up here. So first of all, notice that whereas I was originally in this variable I was originally inside of this return function scope, it's now in the broader scope, which means that it can be accessed here. So we're not going to have a problem when we run this. There's no there's no issue in that storage has been I is within the scope of this higher function, so it's still accessible here. So that totally works. But what happens if we call random JS topic? Let's go ahead and call it like 5 times. So what we would hope is that we get 5 different random JavaScript topics. Oops, actually, sorry, we're only seeing the last one here. Let me throw in console log so that we can actually see all of these. So I'm going to log this to the console 5 times. Okay, so we should get 5 console logs of random JavaScript topics. But we got prototype 5 times in a row. That's statistically very unlikely. This time we got control flow 5 times in a row. So what happened here? Well, what happened is we ran this code once, right? We ran this once, and it created 1 random index. So this line was ran once, and this index was frozen, and we created a closure between this index and this return function. So this thing is frozen. It's always going to be the same index. So every time we run random JS topic, it reaches up here and looks at the same frozen index, which is not a very good randomizer. However, if we move this down here where it actually belongs, now we get 5 different random topics. So instead, what's happening is instead of running it once up here and creating a closure, now it's down in this function scope, which means every time I call this random.js function, both of these lines run. They run differently every time. So you want to make sure that even though closures mean that we can use variables up here, you want to make sure that the logic is in the right place, because if there's a bit of logic that's dynamic, that's going to change a little every time, like randomization, it needs to run every time the new function runs. So we don't want it frozen up here. All right, so that is a bit of a crash course into how scope works. And I want to show you just one more example of how this can be useful. So I'm going to pop back over here and talk a little bit more about closure with respect to the idea of caching. So caching is, principle behind caching is basically saving time. So for example, if I, let's say that I go to a website, like I go to the pre-course GitHub. What is happening is that I'm actually requesting a bunch of code from some server somewhere off in the ether, and then it sends it to my computer and I can see the page. But if I go here, you know, if I keep refreshing the page and go here like 12 times in a row, it would be really time intensive to request that code 12 times. So instead, what my computer does is it actually saves it behind the scenes. So it creates a local copy so that when I refresh the page, it doesn't have to request it from the server every time. And that's a really common technique in programming, is that we want to, especially time or memory intensive actions, we want to save them so that we don't have to repeat ourselves. And caching is a really common place where we use closures. So I want to show you guys a quick caching example, because you're going to do some caching tonight on the homework. All right, so I'm going to create a higher order function called cache exponents. All right, so this thing is going to, we'll just go ahead and say that we're always going to use the exponent of 3. So what we want it to do is create a function or return a function which takes in a number and returns number to the 3rd. So as a little reminder, math.pow is how we do exponents in JavaScript. There's actually a ** operator that we can use too, but I like math.pow. So what we'll do is we'll take this number and raise it to the 3rd power. So if it were 2, we'd do 2 times 2 times 2. So right now, no caching is going on. In fact, this is a totally extraneous way of doing what we're trying to do. But let me just show you how this works, and then we'll add the caching component in. So if I want to create a function called power of 3, I can call a cache exponent, and it will return out this power of 3 function. So far so good. Oops. Let's make sure our power of 3 function works. 5. So that's good, because that's 5 times 5 times 5. We do 2, also works. Cool. So this thing works, right? We're able to call cache exponent, we get out a function, and we're able to run it. But every single time we run power of 3, this line of code executes. And kind of like in that randomizer example, where we wanted the randomizer to execute every time, we might not want this to execute every time. So in the case of power of 3, it's honestly not very intensive to do 2 times 2 times 2. But say we wanted like a power of 3 million. I don't know if that's actually 3 million. But if we wanted to do some really intensive mathematical operation, then what would happen is, actually, let's go ahead and do this. Hopefully, all right, I didn't test this in advance. So if we break JavaScript, or if we break Replit, it's not my fault. Okay, so let's do 10 to the power of 3 billion. It's telling me infinity. Lame. But if this were a little more sophisticated, or if this mathematical operation were even more complex, say we were doing some intensive, analytical calculus operation over here, then in these 3 function calls, we would do that intensive operation once, and it might take, it could take hours. I actually, before I got into software development, I was doing analytical calculus programming, and some of these scripts we wrote literally took like hours to run because they were extremely intensive. So if this took hours to run, and this took hours to run, and this took hours to run, one, that's really stupid because it's the exact same operation that we're running 3 times in a row. We don't want that. So we would want to cache. And I will put this back to 3, even though it's less fun than 3 billion. So let me show you how we would cache. So first of all, we need somewhere to store things. So I'll create another storage. I'll call this storage cache, and it's going to be an object. And we basically want this to contain everything we've already run so far. So if we had run 10, we would want a key called 10, and then the result. So 10 to the 3rd power is 1,000. And then maybe we've run this with 8, or with 2, which is 8. So we want to keep track of everything we've run it on, so that if we're running this function on the same value multiple times, we don't have to calculate it every time. So we'll start with this empty. And then what we do is down here, we want to check and see whenever it's run with a number, we want to say, hey, is storage cache at the number undefined? If it is undefined, then we know we can run it. So we can actually run, we'll calculate number to the power of 3. And then we want to save that result in our storage cache. So we'll say storage cache at number equals result. Get rid of this for a second. Okay, so let me break that down again. The first thing we check is our number in the storage cache? We know that if it's not, it'll be undefined. And the number will always be the key within this object. So we look up the key that is the number, we see if it's undefined, and if so, we go ahead and do that mathematical operation. We calculate the result, and then, of course, we want to save it in the storage cache. So then we're allowed to return storage cache at number. So one of 2 things will happen. Either we've never run the operation on this number, in which case this will execute, and we'll go ahead and calculate the result and save it in the cache. So then by the time we hit our return statement, we'll have calculated it. The other thing that might happen is maybe we've never seen the number before. In that case, we already have seen it. If we've already seen it, then this will be defined. We'll skip the if statement, and we can return it where it's stored because we calculated it some other time. So now, oops, not power. So now when we run this, it's happening behind the scenes, but the first time we run it, we calculate the value. The second time we run it, we just use the cached value. And then the third time we use the cached value again. So to make this a little clearer what's going on behind the scenes, let me throw in a couple of console logs. So I'm going to, first of all, every time we run this function, I'm going to log the storage cache. So the storage cache is out of sight, out of mind. We never actually see it, but it's kind of this hidden engine behind our power of 3. So let's start by just logging the storage cache every time. And I'll go ahead and run this on a few different values. We'll do a couple of repeats. Okay, so now I'm running it, let's see, 6 different times, but only on 4 unique numbers. So now we can see our progress of the storage cache. So the first time we run power of 3 over here, our cache is empty. The second time we run it, we've cached the 10 value from the last time. Now we've cached both the 10 and the 3. And this time, nothing's updated, but we're able to use this cached value. Over here, we now add this new value in the cache. And here, there's nothing new to add, but we're able to use the value. So if we were running this thousands of times, our cache would fill up, and we would save time every time we ran a new function. So whereas up here, we're calculating 10 to the power of 3. Down here, we're just looking up the saved value. And once again, this would be really useful if instead of just doing a simple power operation, we were doing some advanced mathematical technique that maybe would take hours to run. Now we've just saved ourselves hours by caching the value instead of recalculating it every single time. So bringing this back to the idea of a closure, we have created in this power of 3 a closure to this variable storage cache. And I really like this example because it actually shows us that not only can we access storage cache, we can update it. So this variable that exists within this higher scope function is actually available within power of 3, the return value, to be updated and utilized as we go. So this is really where the power of a closure starts to become really apparent. So that is all I have for you guys tonight. Hopefully this idea of a closure and scope are starting to make a little bit of sense to you. Once again, we only have a couple homework assignments tonight, but they are more advanced. So I wouldn't be worried if you're spending a lot of time on each, because that is the idea. They're pretty similar to some things we've seen tonight, so I'm hoping that you can use these videos as a resource. But as always, feel free to Google things, feel free to ask in the questions channel in Slack, and feel free to message me directly if you want, though I always do warn that I'm not always available, so I'm not always able to get back to your question as quickly as you might want. So, all right, that is everything I have for the lesson, but we do have some time for questions. So I'll go ahead and give everyone a minute to collect their thoughts, screw their heads back on their necks, and if there are any questions, please post them in Slack and I will address them. I see we have someone typing in Slack, so let me just give one more minute for those questions to come in. While we're waiting, I'll mention one other thing about caching, which is that what's also cool about a cache is that because it's kind of hidden, it's a really good place to store secret data too. So admittedly, a cache like this is not how you would actually want to store passwords in the real world. But for a very simple example, for like a very simple demo app that uses passwords, this is a great way to kind of keep track of passwords without having your user be able to access every single person's password. Okay, so William asked, how can we use cache in the real world? I assume it wouldn't be in the console log. So the reason I put the console log in is so that we could see what was going on behind the scenes. But this example is actually a way we would use cache in the real world. As mentioned, we probably wouldn't use it with a power function, but if instead we had some mathematical operator here that was extremely advanced and took a lot of time to, took like hours to execute, we would use this. So, but this brings up a really important point, which is what do I mean by using the cache? So as a user running these functions, we never see the cache. We never touch the cache. We never, are directly adding or removing keys on the cache. But we are using it in the sense that it's benefiting us. So even though a user who only had access to power of 3 can't actually physically access this object, it's still benefiting them because it's saving time. And behind the scenes, when this runs, the cache is being updated. So that's how caching works in the real world, is that it's usually out of sight, out of mind, like that browser example I gave you. You don't have to save, you don't have to actually take the time to save a web page that you visit regularly in your computer's cache. It's being saved for you, and it's benefiting you in a way you probably don't even realize, which is that pages are loading faster. Sam is curious about how you might use a cache for a password, like I just mentioned. So I will do a little demo of that. So let's go ahead and create a function called cache password. And to keep this simple, because I can't spend too much time on it, let's say that you have let's say that this thing has a password and a bank account info. So we'll go ahead and create, very similar to the last example, this storage cache. And this thing will be full of key value pairs that are of the form password, bank account. And then we'll return a function where you put in a password and it will return your bank account for you. So I guess this isn't really caching per se, but it's an example of a closure. Sorry, guys, I'm having trouble thinking of a good caching example on my feet, but I will show you this password example. Anyways, so, okay, so we'll do this. Call this thing count. And then over here, we'll just call this account info. So over here, let's say we have, so my password is pass123, and my bank account is 123123555. And then let's say that your password is ABC Joey, which was your dog's name, and then your bank account is this thing. And then we have this other password and this other bank account. So these are all hidden. And then what will happen down here is that we'll actually return the bank account using the password. So there's not actually any caching going on in this example. And I could do a cache example, but it would get pretty convoluted. And I honestly think it might not be terribly useful. So I'll just show you this example because it is another useful example of how closures work. So I am going to get account number, and we'll do account access. Okay, so using this account access higher order function, we create another function called get account number. So here behind the scenes, we just have this master list of everyone's password and bank account. And we certainly don't want the user to be able to access that because then they'd be able to find everyone's bank account info. But presumably, I only know the password to mine. So I say get account number. I can go ahead and put in my password, which is pass123, and it returns out my account. So in this way, everyone's account info is stored behind the scenes, but because of a closure, it's accessible in a way where I can only see one individual account number, and that's only if I put in the correct passphrase. So this is a little example of how we could use a closure to create kind of a password lookup type situation in a way where we have this hidden variable that we're able to access using a closure, but not fully access. So hopefully that gave you a little example of another way that we might use closures in the real world. Of course, in the real world, we would want something more sophisticated going on here for extra security, but that's a little out of the scope of this lecture. All right, any other questions? And thank you, Sam. I am happy that you're always asking great questions because it gives me a chance to explain things better. Okay, it is 6 o'clock and the questions channel seems to be pretty quiet, so I think that we are good to go for tonight. Oh, I see one more person typing, so want to make sure I have all my bases covered. I'm going to wait for Leanne to ask or say whatever she needs to say. Oh, yay. Okay. Actually, Leanne's question is really great. So she was asking about additional resources. And as always, there are resources on your pre-course Get page, and I would especially recommend these. So there's this Understanding Closures with Ease, which is closure specific. There's also this book called Eloquent JavaScript, which is kind of a deeper look at this. So I'd more recommend this. It could be helpful if you're struggling, but it's especially helpful if you want a deeper understanding of what we saw last night and tonight. This might be a better place to start. And just to address this, this feeling of like, what is a closure? I'm not getting it. It really takes practice. To me, what's more important than that you understand what a closure is or the correct way to use that word in every context, make sure that you're just able to write a function that returns a function. That is a good place to start. And then I think that this idea of closure will start to come with time. So for any of you guys who are feeling a little overwhelmed or lost, definitely feel free to just rewatch the video. I think that sometimes this more advanced stuff makes a little more sense on the second pass through. And also reach out in the Slack channel, and myself or the TAs will help in any way that we can. Got a couple more people typing in Slack. Oh, Ellen brought up the resource You Don't Know JS and asked if I've used this before. I actually have a long time ago, and I remember it being pretty good. I'm not as immediately familiar with it as the others, but that is a great resource. Ellen, would you mind actually linking that in the Slack channel so that people can get to that easily? All right, so we have some resources available. It sounds like both on here, and hopefully Ellen will link that in the Slack channel. If not, I can look it up and link it for you guys. And as another reminder, closures are extremely advanced. We're really talking about some of the most advanced, most mind-boggling JavaScript stuff here. And the idea is not for you to be a closure master. It's for you to start to get your feet wet. So play around with the homework, try to compare it to some of the things I did in the lecture tonight. And if you guys get stuck, definitely reach out. Well, thank you guys for sticking with me tonight with closures. I hope you're all having fun and your brains aren't hurting too much. It's kind of sad to say, but we only have 2 lessons left. So I will see you guys tomorrow and I will see you guys Thursday. And then that is it. And I hope you guys are feeling like you're starting to get a hang of this. And if you are interested in the main curriculum, I hope you guys are really excited to start to get to master these topics, because as I keep saying, we're really just scratching the surface on all the really amazing stuff that we can do in JavaScript and build in JavaScript. And it really starts to get fun once you get deep into it. So I hope you guys are excited for the main curriculum. All right, that is it for tonight. And I will be here tomorrow night to teach you guys all about recursion, which is my favorite thing to teach. So definitely be here. All right, have a great night, you guys. I will see you tomorrow.